Hi everybody, in today's video we are going to start chapter 7 with multiplying and dividing rational expressions. Now remember, rational is another word for fractional, so in this chapter we're going to be looking at fractional equations and functions and expressions. We are going to need to factor these expressions and then perform operations like multiplication and division to simplify them. So today we're going to focus just on those first two operations, multiplication and division. We will add and subtract in the next video. So as I said a moment ago, a rational expression is a fraction in which the numerator and or the denominator are polynomials, meaning you're going to have x's, you may have some x squareds, x to the third, that kind of thing. If you have a rational function, it's of the form f of x is equal to p of x over q of x, where p of x can be a polynomial and or q of x can be a polynomial. It is worthy of note that q of x, the denominator, it can't equal to 0 because then you'd be dividing by 0 and that's undefined. And a rational expression is simplified if both the numerator and the denominator have no common factors other than 1. So what we're going to be doing is a lot of factoring and then dividing out the things that cancel or divide out, so that we're left with only the unlike portions or uncommon portions of the numerator and the denominator. So let's get into this. When you are asked to simplify a rational function, we're going to factor both the numerator and the denominator, and then we're going to do any dividing that we're able to do. So if we look at this example, the numerator says 3x plus 6. This has a GCF of 3, so my first step is going to be to factor out that GCF of 3. And then once I've done that factoring, you can see that we have 3 times this quantity and it's divided by 3. So because this is held together with multiplication, those 3's divide out and it leaves us with the simplified expression x plus 2. And that's our final answer for that one. It's fully simplified. So we can divide anytime we have a factor. What this means is we cannot divide out individual terms. So for example, in this problem that we just did, I can't do 6 divided by 3 is 2 and leave it as 3x plus 2 because that denominator is a common denominator for both of those terms in the numerator. It means that the part that you're dividing out has to be connected to the rest of the numerator or denominator with multiplication. So here, this little multiplication sign that I drew is really important because this part that I was dividing out has to be connected to the rest of the numerator with only multiplication. In order to divide out this x plus 2 term, I would have to have multiplication holding it to something else. I cannot divide just this 2 because there's a plus sign holding it to this x. This piece functions as one unit that is not going to divide out in pieces. It's all dividing out or none of that x plus 2 is dividing out. And you're going to see me use parentheses throughout this unit to indicate those pieces that have to stay together and get divided out altogether. All right, so let's look at some examples. In this first problem, you have x plus 6 divided by 3. Now, it may be your gut to do 6 divided by 3 and change this to x plus 2. But because this 6 has a plus sign in front of it, this is all one factor. So it all goes or it all stays. And in this one, there's not an x plus 6 down in the denominator, so we can't divide it out. There's also not a 3 being multiplied up in the numerator, so we can't divide the 3 out. This one is simplified. All right, in the next one, I see a bunch of x's up in the numerator, so let's take out a GCF. Both of them have x squared, so that is x squared times 1 minus 7x, and that's all divided by x to the first power. If this is x to the first power and that's x squared, that means this one's going to divide out with one of those and there will be one left over because 2 minus 1 is 1. And so our simplified answer is x times 1 minus 7x. In the next one, do you see anything that can divide out? We cannot cross out this x to the third and x and do that division because this term is part of this larger expression. It's held together with subtraction right there. So I don't see a GCF in the top, and I can't do any dividing out of that factor with a matching factor in the denominator, so this one is already simplified. Okay, so let's look at this next one. The top has a whole lot going on in it, doesn't it? I see that there's an x plus 1 minus another x plus 1, and you've got this x out here, so we can take that out as a GCF. So if we factor it out as a GCF, we're pulling out the x plus 1, and the leftovers, that's these parts here, are x minus, and then there's a 1 there, so there's a 1. And then down in my denominator, I have x plus 1, that factor. Now here's an example of where those factors are, that are binomials are going to divide out. There's an x plus 1 in the top and also in the bottom, so they divide out, and that leaves us with just x minus 1. All right, let's do one more of these. So looking at this one, I see that I have x minus this term, x plus 1, but because it's held together with a minus sign and not multiplication, I cannot divide these two guys out. Now this minus sign, that is a negative 1 right there, so why don't we start this one by distributing that negative 1 into the set of parentheses. So we have x minus 1x, negative 1 times 1 is negative 1, and that's all over that factor of x plus 1. And then from there, we have x minus x. Well, those cancel one another out when they subtract, so that leaves us with negative 1 divided by x plus 1, and that doesn't simplify any further. Now let's get to the multiplying. We are going to do some multiplication and some simplification. We're going to factor the expression as much as we can and divide out any common factors, which will help us to simplify as well. So looking at this first problem, there's a whole lot going on in this problem. So what I want to do is, before I start slashing things out, I want to do some combining, some multiplying, just in the two numerators and just in the two denominators. Because this is multiplication, we can multiply stuff from the numerators straight across, and the same thing with the denominators. Because I'm going to be canceling things out, though, I am not going to do 5 times 27 and get a gigantic number. I'm just going to write that for now as 5 times 27. And then I have x's in both. I have x squared times x to the 5th. When you add those exponents together, that gives you x to the 7th power, and then you have that y to the 3rd power also. Down in the denominator, if we do the same thing, we have 3 times 15. I'm not going to multiply those together to get a big number. We have x to the 1st power times x to the 4th power. We add those exponents together, so that's x to the 5th. And y to the 4th times y to the 1st means that we have y to the 5th. So now I'm ready to look to see what divides out. Do you see that you have a 5 and a 15 in the numerator and denominator? 5 divided by 15 is 1/3. And 27 divided by 3, that's 9. So those all are going to divide out in some capacity. When I look at my x's, I have x to the 7th in the numerator minus 5. That means I'm going to lose all of those x's from the denominator, and 7 minus 5 is 2, so there are going to be 2 left in the numerator. Now looking at my y's, I have 3 minus 5. The 5 is the larger exponent, so this one is going to divide out and have leftovers down in the denominator. So all of these 3 y's are going to disappear, and there are going to be 2 more that are left down in the denominator. So now that we've done all of that dividing and canceling, let's see what we have left over. In terms of coefficients, we have 1 times 9. so that's 9. We have an x squared, and that y to the third all divided out. In our denominator, we have 1 times 3, and then the x to the fifth divided out, but we still have y squared. Now we're not quite done. There's a little bit more simplification we can do with this 9 divided by 3. 9 divided by 3 is 3. So that means our final answer is 3x squared divided by y squared. So really what we're looking at here is doing as much division as possible, and we need to factor first in order to do that division. So let's look at one where we actually have to do some factoring. All right, so in this first problem, you see a bunch of polynomials. We are going to factor everything that we can first. So let's look at this x squared minus 4. This is a difference of perfect numbers, so that's the same as x plus 2 times x minus 2. The x cubed plus 8, that is a perfect cube, because that's the same thing as x cubed plus 2 cubed. So when we factor that using the SOAP method, we get x plus 2 times x squared minus 2x plus 4. Remember, this is same, opposite, always positive. In order to get those values in the trinomial, I squared the first term, the x, to get my x squared. I multiplied the 2 together to get 2x, and I squared the last term, 2, to get the 4. All right, then looking over at this one on the right, the numerator here, this one is prime. I can't factor that because I can't use the same sign. I can either use 1 times 4 or 2 times 2, and neither of those with the same sign add to negative 2. So that one is prime as it is. And then this guy has a GCF of 5, so when we take out that 5, that gives us x minus 2. Okay, so just rewriting this all now so that it's a little more clear. You have x plus 2 times x minus 2 divided by x plus 2 times x squared minus 2x plus 4. And then this is multiplication, so I'm going to put it all over the same bar here. That one is all stuck together because it was prime. And then you have 5 times x minus 2 there. All right, so we're ready to see what divides out. You have an x plus 2 in the top and bottom, so those divide out. We have an x minus 2 in the top and bottom, so those divide out. And we have an x squared minus 2x plus 4 multiplied in the top and bottom, so those divide out. So if we look across our numerator, we're not left with any of these values, so that's going to be a 1 for our numerator, and in our denominator we have that 5 left over, so our simplified multiplication gives us 1/5. Let's do another one of these. Looking at what factors first, in the numerator of this first one you have a GCF of 2x. When we divide out that 2x or factor out that 2x, it gives us x minus 5 left over. The denominator is a difference of perfect numbers, so that's x plus 5 times x minus 5 when we factor it. And then looking over on the right, none of those are going to simplify at all, so I'm just going to go ahead and multiply and put them all under the same bar. Okay, so we're looking to see what divides out. I have a 2 in the numerator and the denominator, so those divide out. I have an x to the first power up top and x squared in the bottom, so the x to the first power is going to divide out one of the x's and leave one more down in the denominator. These x minus 5's divide out. I don't have an x plus 3 in the denominator, so I'm stuck with him. That means I have x plus 3 left in my numerator, and in my denominator I have x plus 5, and I also have this x to the first power, and that is my multiplied and simplified expression. All right, let's shift and talk about division now. For division, we are going to divide rational expressions that are rational functions the same way that we divide just regular fractions. We need to keep, change, flip, and then multiply. So we are going to keep this first expression exactly the same. We are going to change the division sign to be multiplication, and then we are going to flip the last expression. So the numerator and denominator are trading places. That's x squared minus 100 divided by x squared plus 3x minus 70. All right, so now this is a multiplication problem, just like what we were just doing. So let's factor everything and then see what divides out. This first numerator here, that's going to factor to x minus 7 times x plus 3. The denominator has a GCF of 5. And we're multiplying that by this numerator, which is a difference of perfect squares. So I'm going to write it as x plus 10, x minus 10. And the denominator, let's use 10 times 7, because that'll give us a 3 inside. So that's x plus 10 times x minus 7. All right, so let's look and see what divides out. We have x minus 7 in both sides. We have x plus 3 that divides out. X plus 10 divides out, and that leaves us then with x minus 10 divided by 5. Remember, you cannot divide this 5 and 10 because this x minus 10 has to be stuck all together. It's one term, one term. So this 5 cannot be divided out with that 10 because it would leave this x, and he has to go when the minus 10 goes as well. Let's do a couple more to practice these. All right, in this first one, it looks a little funny, right? Because on the right, you have this expression that's not a fraction. If we want to think about it as a fraction, we can put it over 1, because any number, any whole value can be put over 1 without any changes there, and then we're ready to keep, change, flip. So we're going to keep this first one the same. We're going to change the sign to multiplication, and then we're going to flip this last term to be 1 over 3x squared minus 2x. Okay, we are ready now to do our factoring. If you're looking at this first one and going, whoa, there's not a GCF in that, that means I have to factor by grouping. That's a whole lot of work that I don't feel like doing today. You also should remember that we talked about the app in your calculator that can help you with factoring by hacking that polynomial solver app. So I want to use this as an opportunity to review that. If you're not feeling super comfortable with factoring, you can do all of the factoring except for the GCFs using this app in the calculator. You do need to take the GCF out before you factor using the app. So in order to use this app, we're going to hit the apps button, and then we are going to do polysmalt 2. In my calculator, this is option 7. In yours, it's probably option number 4. Then we're going to choose the polynomial root finder because we're working with polynomials, and we need to set the mode to match the polynomial that we're about to plug in, which is this guy here. So the order is 2 because this is a quadratic. I'm going to change my solutions from real to a plus bi, or complex, and hit enter. I also want let's see, everything else, yeah, those all look okay. If you have an option for fraction, you may want to change it to fraction rather than decimal. Mine's set up to do that automatically. And then in order to hit the next button, I'm going to hit graph. Okay, so I'm ready to put in my coefficients. My first coefficient is 3. My sign is a plus sign. My second coefficient is 13. Then I've got a minus sign and 10. Your calculator may ask you slightly differently. It may say A2, A1, A0. You're just putting in these coefficients, 3, 13, and negative 10. Once I've got those plugged in, I am going to hit solve by hitting the graph button again. And it has given me 2 solutions here. Now remember, when you are given solutions, x is equal to 2/3 and x is equal to negative 5, we need to turn those into factors. For the x is equal to negative 5, remember that's x plus 5 when you turn it into a factor. and the x is equal to 2/3, remember this denominator, it moves up to be multiplied with the x. So that's 3x, change the sign, minus 2. That means that 3x squared plus 13x minus 10 factors to 3x minus 2 times x plus 5. So again, you can use this app whenever you have access to a calculator to do any factoring for you besides the GCF. You have to take out the GCF first, and then you can use the app to factor it the rest of the way. All right, so let's keep going with this problem. I've got the 6x squared, and then when I look over at the one on the right, I do have a GCF of x. So I'm going to take out the GCF, and that leaves me with 3x minus 2. All right, let's see what we can divide out in this one. I've got a 3x minus 2 on both the top and bottom, so those divide out, and it doesn't look like anything else divides out. So multiplying across the top, 1 times x plus 5 is just x plus 5. I have a 6 in the denominator along with x squared times x to the first power. When I add those exponents together, that gives me x to the third power, and that's my final answer. Okay, so let's do one last one, and this, I know it looks like there's a whole lot going on. Do you see that this is a complex fraction in that there is a fraction divided by another fraction? The first thing you should do with a problem like this is rewrite it so it looks like the problems that we've worked with before. The first fraction, the one that's on the top of this complex fraction, we're going to write just like normal. And then we're going to put the division sign and then write our denominator, that bottom fraction. All right, and then from there, this problem is the same. We're going to keep, change, flip. Changing the operation sign to multiplication and then flipping the second fraction. And then we are going to do all the factoring that we can. So let's see, for this first numerator, we can do x minus 9 times x plus 3. In the denominator, you have a GCF of 2x. So that gives us x plus 1. And then over on the other side, you can factor the denominator using 9 and 5. And then we're looking at what we can divide out. So we have x minus 9s in both the numerator and the denominator. There's an x squared up here. That's going to divide out with one of the x's down in the bottom. Oh goodness. There we go. So there's going to be one left there, and all those are going to divide out. And that looks like it's all. So we have x to the first power times x plus 3. And in our denominator, we have 2 times x plus 1 times x minus 5. And that's our final answer there. Okay, so in this video we worked a lot with factoring expressions. Remember, you have this app that can help you if you're having trouble factoring. And then after factoring, we also performed operations, multiplication and division, to simplify rational expressions. We divided out everything that we could. So go ahead and give those Now You Try problems a try.